Okay, chalo guys, I think we can get started. I hope you guys are on channel 2. You're able to hear me? All good?
And me? Am I audible? Okay.
Great. So, hello everyone and welcome to the third edition of ETHIndia. It's really great to see you everyone in person after like long 3 years due to the COVID. So here, myself Thrilok and my teammate Shriya are here from the team Instadapp and we are going to show you how to build the DeFi dApps on top of Instadapp Smart Wallet. So Shriya, I have a question for you. So, uh, st- so, so I have a question for you. So I have some idle ETH lying in my wallet. So I was thinking maybe to deposit that in Lido for some rewards. They were mentioning that I'm getting almost 4%. So what do you think? What's your opinion on that?
Well, Trilok, you're right. Lido is offering around 4% rewards of staking on your ETH. But how much idle ETH do you have?
Around 100.
100 ETH. You're a big man, Trilok.
Oh no.
But although, what if I tell you that not just 4%, but using your 100 ETH, you can gain almost as high as 7 to 8% rewards?
Whoa, that's really interesting. But how is that even possible?
So, Trilok, it's possible by using a financial strategy called as leverage. So leverage is when you sort of increase your exposure to some assets. So if you can see that this is how your position will look like. In the first case, this is you just holding your staked ETH, earning the regular 4% APR. And in the second case, you're going almost 2x leverage, earning around 7% APR.
Whoa, that's really interesting. But how is this even possible in DeFi, decentralized finance?
So in DeFi, this is how you should go. Now this is you holding your 100 staked ETH. Now you can deposit your 100 staked ETH into Aave. Now, on Aave, you can borrow against your staked ETH up to 72%. So now you borrow some ETH from Aave, you swap this ETH into staked ETH, and now you deposit it back. So as you can see that your collateral has sort of increased, so you can obviously borrow more against your collateral. So you borrow 28 ETH more to sort of go 2x, which is 200 staked ETH. You swap it back, and you deposit it again. So there you have it, your 2x position.
Oh, whoa, so like this I can earn up to 7%.
Yes, that's right.
But here if I see it almost took like 7 transactions. I think it's will be a bit time taking and for me to research how, like I don't think it might be feasible.
Well, look, you're right. It is time consuming. And don't just get me started. This is you going just 2x. Let's say you want to increase your reward even more and you want to go 3x or even as high as 3.5x leverage, which is the maximum that you can go. And if you see that it takes you almost 16 transactions to go 3x leverage, but your APR at the same time is going to increase to 10%. And in 3.5x, it's almost as high as 12%.
Oh. But I would really like to have more than 11% here, but I'm not sure if I can do more than 16 transactions.
Well, Trilok, so this is where Instadapp comes into play. Instadapp provides these complex strategies available to the users in just one click. And such strategies are available on top of so many protocols like Uniswap, Aave, Compound, etc. And you would be shocked to know that Instadapp is currently managing around 1.7 billion TVL.
Whoa, isn't that very huge, guys?
Well, it is. So, now, let me tell you how you can sort of achieve this strategy available in one click. So to achieve this in one click, we sort of use something called as a flash loan. So now, mind you guys, you will be just doing one transaction, but I will be breaking that down into a set of actions that will be performed sequentially. So this is your action stack. Now, again, we started with 100 staked ETH. Now we flash borrow 100 ETH. We swap this to staked ETH. We deposit the 200 staked ETH that I now have. I borrow 100 ETH. And using the borrowed amount, I pay back the flash loan. Now, since this is a transaction, but it has not happened on chain, so it has not yet executed. So we need to execute this transaction so that your balance get updated on chain. So we cast this action stack, and this is how your position looks like in the end.
Oh, that's real. Yeah. Oh, that's really cool. So if it's really taking one transaction, I think it's like doable. I would love to see how is that even possible. Maybe I would try to go by
Hello.
3.5x to get maybe the 11% that you were showing in the previous slide. Is that even possible?
Well, yes, Trilok. So here's the catch. Now we just went 2x. Now, even if you have to go as high as 3x or 3.5x, you can see that your APR is increasing, but your number of transactions just stays the same. And that is possible because now you're just taking a higher amount of flash loan. So now, Trilok, I have sort of conceptually explained you how you can achieve this. Will you be able to show our fellow developers how you can code this out?
Sure, I think that would be interesting and everyone is looking forward for that. So, Instadapp offers a advanced Web3 based online editor that lets you to interact your DeFi right from your browser, and that we call it as Playground. So, in the Playground, we have TypeScript and HTML supported too. I guess most of you guys would be using VS Code or some code like editor, right? But what if you had the same visualization for VS Code in your browser? The playground is built using the same architecture or the same libraries to give you the same VS Code like feel. And then, have you ever wondered you can import your NPM packages in your browser? It's possible using the ESM automated library import. And not only that, in your browser or in your playground, you can use natively big number library, Axiom, and then the await, the top level await. I hope in blockchain or DeFi, you guys might have to do a lot of asynchronous calls. That you can do it easily. And then,
Okay, Trilok, so I think you can get started. And don't forget to log in using your GitHub or email so you can share me a link and I can cross-check whether you have written the right code.
sure. So let's get started with the demo. So I'll be showing you guys how to code in just like 10 minutes, how to code a leverage strategy. So before that, I'll just give you an understanding of what's Playground and how the Playground is connected with our main application. So this is our main application. This is our Instadapp main application. So in this application, we have a feature called something as simulation. So when you turn on the simulation, you can actually do all your work, like whatever you want to try it, without really spending. So that means it's like a testnet environment. You're actually converting your main application into your testnet environment. So I've turned on the simulation. So let's assume that we have turned on the simulation. I've turned it on over here. And in the same way, once this has enabled, it will show you that this model, that you can do all this, like all the transactions. Like let's assume that you want to, before using your real funds, maybe someone is like putting real money. Then before doing all the real transactions, you can really test it out on the simulation. So now, the simulation mode has been turned on, and it gives you 1 hour of time to do whatever transaction you want. And then, this is the playground.
Top up the balance.
And here also, I'll link the simulation. I'll link the main application's simulation with the playground. So I'll connect like this. So once it's connected, both the playground, the code over here and over here, it's connected. So let's see. So when I go to Aave V2, so do you see any funds over here? No, right? It's currently empty. So now, this is already like the pre-script written that whenever you kind of first time go to it, you will be able to see this. So what this basically does is that it tries to deposit ETH. This is the ETH address that we use to have a proper convention. And this is the connector. So Instadapp Smart Wallet. So Instadapp Smart Wallet can interact with the protocols using something called as a connector. A connector is an intermediary contract that helps the DSA to interact with the protocol. So the connector has all the logics. Suppose, let's say, you had to give the allowance and then deposit. So the connector handles allowance and the deposit for you. So you just need to call something like this. And also, you guys might be wondering why this is in JavaScript and why not in Solid and how I'm exactly interacting. So the playground is built on top of a DSA Connect SDK. What it does is that you can interact with your DSA Smart Wallet directly with the JavaScript. So you can just write the code. This is the connector that how you're going to interact. So now, here I'm just going to change the amount. Maybe let's take 134, I think 13.45. This is the amount that when I run it,
You don't have balance. You need to top it up.
okay, I think I don't have a balance. So on simulation, we have a feature that you can get the test funds. And we just call the top up function over here, and then we just put 100. And once that is top up, you will be getting, like it's like your test tokens. If you have been on a testnet or anywhere, you will be going to the faucet, right? So the same way, we have our own thing called as top up, where you will be able to top up 100. So once this is top up, I'll call it. And now it's showing casted to spells and the transaction hash. So let's see what happens. Now I'll try to reload the dApp. Since the internet is a bit slow, it's kind of taking time to load it. So here, if you see, I've deposited whatever the amount that I've entered over here was exactly deposited over here. So you will be able to see. So that's how you can connect the playground with the real app, and then you have a visualization to also look into it. So now, I've explained you what's playground and then what's the main application, how they both are connected. And also one more thing, just to give you a short brief of what are the components there on the playground. So this is the left side is the online editor, right side is the console. If you remember, I've said it supports HTML2. So when I click on the toggle, at the bottom, it shows me the HTML editor, and the right side, the preview of the HTML. So for now, I'll just turn it off. This is the simulation button where you can connect the simulation with the main app. And then we are supported on 5 chains. Here you can see the 5 chains. Then a person or an owner can own multiple DSA accounts. So since he can own multiple DSA accounts, you can toggle between them. So now, for now, what I'll do is that I'll create one more DSA on our main application to get started with the leverage strategy. So so this is how I'll be creating. I'll be just calling the new over here. And then it will create a new DSA for me. So the new DSA is this, actually. So this is the ID. So you can see the ID over here. And this is my DSA address. And a DSA can have multiple authorities. So this is the address that I'm connected on MetaMask. This is my EOA address, and this is my owner. So my owner, my MetaMask address, controls this DSA. There are different types of authorities also. I'll explain you later when we go on to that slide. So now, I've created a new DSA. Let's see here also if it's there. Here, if you see, it's 358820, and here also 35. Sorry, it's 23 at the end, and it's 23 at the end. So now I'm on the same DSA. So let's get started with the leverage transaction. Before starting, as Shriya explained, I initially had 100 stake ETH. So let me top up 100 stake ETH. So here it shows me I've added 100 stake ETH. So in my balance, I should be seeing 100. So now we have our requirements set up. Let's get started with the coding. So I have some pre-code written. Those are just like addresses and all the stuff. You can just find it over the Ether scanner anywhere. And the amount that I'm going to start is with the 100. Since you all guys know, we can't directly use the Ether format of a number or an amount. We have to convert it into V. So we have converted this amount into V format by multiplying it with the 10 to the power of 18. And now the leverage factor. So in the leverage, as we have seen in the diagrams, I'm going to explain you with only the leverage factor of 2. So the leverage factor is 2, the leverage amount. So if you guys see over here, in the leverage factor of 2, the amount was 200 stake ETH. That is, I need to have at the end 200 stake ETH. So the amount that is going to be over here is going to be the amount in V times this one. Now as Shriya explained, first we need to take a flash loan. Have you ever wondered, like, what if there was an autocomplete where you just call, take flash loan, and it automatically gives you the flash loan code? You just don't need to remember. You can just use it directly. See, it gives you the autocomplete. And here is the where you add the spells. So in flash loan, you have to mention the address that you want to take, the amount, and the route, the flash loan fee, and everything. You can dive deep into it on our docs, which is available. For now, those are set as constant, 5, and the flash loan fee is set as to 5 basis point. So the flash loan token. So here, in the example, we have taken 100 ETH. So in the same way, I'm going to take 100 ETH. Also, we have the wrap ETH address as autocomplete. So if I just type wrap ETH and press enter, I get this. Or else, since I've already saved at the top, I can just use that one itself. And the flash loan amount. So now, how much amount do we need? We need 100. So the amount in V would be the flash loan amount. So that's it. So you have the flash loan ready, flash loan spells ready. You have to just add the required spells. And also, once you have taken the flash loan, there was a requirement to swap the ETH into stake ETH. So now, again, we use, for the swap, we use 1 inch. So to use 1 inch, there are like a lot of setup you have to do. So we have simplified that on our DSA. And also, we have autocomplete for swap. That's it. You can see you have a swap spell also ready. You have to just mention the sell token. That is, what we are going to sell? We are going to sell the wrap ETH to stake ETH, and the amount would be the flash loan amount. And the amount and the slippage, I'm setting it to 1%. You can increase it according to your requirements. And this is the swap spell. Here, the swap connector ID. So all the connectors on our smart contract level are linked with an unique ID, and you have to just mention that. So you don't have the hustle of remembering the connector address and stuff. We faced that in DSA V1, so we made it easy for you. So this is the ID, and the name of the action is sell. I sell the byte, I'll try to buy wrap ETH, I'll try to buy stake ETH, and I'll try to sell wrap ETH, and the amounts, the event, and everything. You don't need to know right now. You can go into it maybe whenever you're diving deep into the docs. So now I have the spells also ready for the swap. Now I think I have only 2 spells required. That would be deposit and borrow. So now, how will I get the connector ID of Aave V2? Let's say in the first thing I've been shown you. So you can go to our docs. You can navigate to the connectors, the mainnet. You can go to Aave V2, and here you can see a deposit spell. The deposit spell, the connector ID, and then the arguments. A description for that is also available. So again, I'll be using a autocomplete to have the basic structure of the spells to add ready, and then I'll be just entering. And then I have to deposit. What I'm going to deposit? The stake ETH. Did you guys have any question or anything why here it's 200 and why here it's 100? You had any questions? Maybe we can do it in the Q&A. For now, so we'll be depositing the stake. and the amount. So the amount would be the leverage amount. So we are going to deposit 200. And then the set ID and get ID is 0. You can understand them later, maybe once you dive into the docs. Then the other spell that is required is borrow. So I have to borrow 100 ETH so that I can pay back the flash loan. So I'll be again calling add spell autocomplete. I'll be writing away V2A borrow, and I'll be just mentioning the parameters. So these are the parameters. Now we have our leverage spells ready. The only thing here, if you have also seen, okay, so the payback of the flash loan was already added over here when I've used the autocomplete for the flash loan. So it's already there. So that I've skipped. But now since we have our all the spells ready in a sequence for the leverage strategy, now I have to just cast them. So executing the action stack or the spells. So here, so this is how I cast it, and I'll be getting a transaction hash. So let's again jump into the Aave dashboard on our main application. Here you'll be see it's empty. We have 100 stake it, all the requirements looking good. The next part would be just casting. So I'll be calling this, and now it tries to cast it and gives me a transaction hash. The transaction was successful. Now let's see what happens, what I see over here. So here if you see, 200 stake ETH and 100 ETH, the same thing what Shriya has told you, that how the position would be looking. So in the 2x leverage, 200 stake ETH, 200 stake ETH, and then 100 ETH. And now the APR is 7.2. Here you can see the net APY also. The rate is currently 7.2. And that's how you can do, that's how you can build your own strategies or the spells, and then you can connect them or maybe create your own application or a DeFi dApp. Also, you guys might be wondering, I've said that you can build your dApp, but there is no UI, it's only the script. So for now, since it's kind of, it might take a bit of time me to explain HTML, so I've already have the pre-code written where if I turn on, and I have a UI also ready. And then I can share this link with Shriya. So Shriya can actually just enter the amount and will automatically do the 2x leverage for her. So now we have built a dApp just in few minutes using Playground. And that's Playground.
Well, Thrilok, the demo was really amazing. So as you can know, that Instadapp also has a product which is the Instadapp Lite, which also uses the same strategy, which is the STETH leverage staking, and provides around 8 to 9% of APR on the yields. It is currently managing around $200 million of TVL, and you almost wrote that code, around the 70% of the same code, in just 15 minutes.
So isn't that amazing?
It feels so. So yeah, so building just on top of Instadapp and DSA account is just as easy as this because of the Playground and the development environment available. So let's switch on to some question and answers if they have.
Yeah, if you have any Q&A, you can ask them.
Also, no, it's fine. Sorry.
So you guys have any questions? Any doubts? Just a second, let us wear the headset, then you can ask.
Yeah.
Hello, can you hear me?
Not
Very
exactly.
faint noise.
Can you hear me now?
Not exam, not able to hear.
Hello.
Hello, hello, hello. It's coming. But the mic, that mic is not coming. Yeah, I think it's working.
Hello.
Yeah, it's working.
So I was wondering if does the SDK or the playground provide anything that the website does not provide out of the box? So can you give me an example of a strategy?
Okay. So currently, whatever the strategies that we have on our main application are also built using the same SDK, that is the DSA Connect, and the SDK and the application also use the same set of sequence of the spells. So maybe if you want to have a strategy that is not available on our main dashboard, could be lot. It could be person to person, but we have only added the topmost strategies which our users were looking for. So that's why we have added. Maybe if you want to build something, maybe a new strategy where, let's say, you want to do something like this. You want to borrow. Sorry, first let's say you want to deposit ETH into Aave, borrow DAI, and then deposit into compound. Maybe let's say there was some strategy that was yielding you much higher yields. So in this, you can just combine them in the sequence of series, and then you can build it. And then you can share it as I've shown you how to share it.
Yeah, I do have another question.
Yep.
So does the SDK support only the platform supported by Instadapp, or can I go for a custom platform like some other lending protocol?
Okay, so that's a nice question over here. So basically, as I said, Instadapp and the Instadapp Smart Wallet and the protocols can only interact via the whitelisted connectors. That means first we need to build the connector that is written in the Solidity or the smart contract. And once that is written, and that has been whitelisted. Once that's whitelisted, and then you will be able to interact. So now, assume that Instadapp is like a OS. So once we have added the connector to this OS platform, you can create a n number of combination with the other strategies. But we have to add that connector because we kind of follow some standards and some security concerns where it makes this all the things, whatever I've shown you, makes simpler for you guys. Anything else?
Thanks. Yeah.
Okay, great. Anyone, any other questions? Oh, great. Hey,
My
hi.
question is actually extension of like why DSA is controlled by an EOA, right? An owner. So why can't owner do any arbitrary transactions from DSA?
Sorry, what was the last thing? Any arbitrary?
Any why can't like right now owner has to do the transactions that from list of connectors, so it can only interact with only certain amount of protocols, but why can't owner do arbitrary calls to any contract?
Okay, so now, as you all know, EOA can do only one transaction per time. So EOA is the external own address or the MetaMask address, whatever you see. It can only do one transaction, like one action, because we don't have a batch run anywhere. There is no like a standard that's been followed where you can batch all these things. So Instadapp has done that for you guys, where we have created the standards where all the protocols, as I said, right, the connectors follow a standard which makes you composable between different protocols. So now, what you say, a DSA can be owned by any address that can do a small kind of a transaction that could call the DSA. The owner can be an EOA, the owner can be a Genesis safe or any other smart contract too. Anything, owner can be anything. And then in the authorities, you can have different levels of permission. This is not available on the main application yet, but but currently we have only one kind of owner, that is the full access owner. You could have manager, guardian, and the automation. The manager is now whatever the owner has the access, right? He can access all the connectors. That means he can access the security, he can access the funds and everything. But the manager has only limited amount of access. Maybe let's say he can just interact only with the compound, He can't interact with the Aave. So that's a manager type of authority. Then the guardian. Guardian just helps you to recover in case you have lost the owner address. Let's say your MetaMask private key. Maybe the guardian can help you. and then the automation. Automation is just like a thing, like whenever the market is crashing or something, the position you have seen, right? In those cases, if it has to save, it has a limited fixed strategy that it can execute. So automation can execute a fixed strategy. So that's like an automation authority. So was your doubt clear?
Yeah, that's right. I just wanted to ask that is there any way a connector can be added
You
where
can.
connector allows arbitrary calls?
Okay, so for the security reasons, we haven't added a connector that can do a arbitrary calls. Like you can't just call any direct random contract. That's for the security reasons. So if you want to, maybe in the hackathon, if you want to build, you can build a connector. You can add it to the Instadapp on the testnet or on the mainnet fork. So if you want to building on top of where you need a custom connector, then you can build your own connector, and then you can just create like a mainnet fork environment, and then you can do it. But currently, the adding of the connector is done by the DAO.
All right, makes
Yeah.
sense. Thank you.
Okay. Any else question? Any other? Okay.
Thrilok, so the other team also has a workshop, so we won't. Maybe after this question.
Okay, so I think we are running out of time. We'll be at the booth and we'll be around. So this is our Discord channel. You can just connect and ask questions. That's our Twitter handle and our email address. If you're building on top of Instadapp and if you have any questions or anything, we'll be around, or you can email us, or you can come on to Discord. All right, guys. All the best for your hack.